Hey everybody, welcome to episode 7 of Pizza Legends. In this video, we're going to focus on basic walls and collisions. Our character can move around the map right now, but a little too well. There are currently no rules or limitations on which spaces can't be moved to. By the end of this, objects will actually take up space and the whole scene will feel more tactile. A reminder to check out the whole playlist below if this is your first time here. Let's get started. So let's hop over to the browser and see what we're going to do today. Here's our game like we left it last time. You can see I can walk the character around, but when I try to walk into objects in the map, like this table here, or even other game objects like this person here, the game lets me like barge right through them. Same with the walls up here. What we want to do is set up a system where certain spaces on the map can't be walked to, and we're going to call those walls. So let's hop over to the code, and in the code base here, we're going to open up our file called overworldmap.js. And in the overworld map class itself, we're going to set up an object that's going to keep track of all the wall spaces in our map. So at the very top here, how about right here? I'll say this.walls is going to be a new object. But as always, we're going to be able to pass in, of course, our objects for this map. So we'll say config.walls. And then if we don't provide anything, we'll default to this empty object. So going to our demo room configuration object here, we're going to need to include a new bucket for walls. And I'll put that right under game objects here. Give us some space. Walls is going, like we said, it's going to be an object, and the key of each value in the object is going to look like this. It'll be like 16, 16, and that's going to be like 1, 1 under the hood. But of course, we don't want to author like this. We're going to make a utility that's going to kind of automatically set up these values for us, and then each one of these will be like true. We're using an object here because we're going to have a lot of walls, and if we were using something like an array, we'd probably have to iterate through each wall on every frame, and that could be slow over time, especially on really large maps. So the object here is going to give us a really clean lookup on any given space. So our utils is going to look like this. Let's just comment this out and say utils.asGrid chords. And we haven't created this yet, but we will in a second. We're going to pass in an XY value. And I just happen to know that one of the walls we're going to want in this map is space 7, 6. So I'll put that there, and then we'll make this true. And if you've never seen this before, these brackets here on the left side that surround the key, that's a way in JavaScript to make a dynamic key. So if you don't know exactly what it's going to be, you can kind of have the code figure it out. This will evaluate to a string, and when it's all done, it'll end up looking just like this. Different values, I guess, but you get it. Actually prefer if this be singular, so like asGrid chord, and then let's go ahead and define this. So I'll open up our utils.js file, which right now we only have one util. We're going to add a few more today though. So here's our first one that we just made, asGrid chord, and again this takes in an x and y. This is just going to return a string that's our x, y, but base of 16 separated by a comma. I like to use a comma here so it makes it safe for negative numbers. We won't use any negative coordinates in this game, but say we did, a system like this is going to be okay with that negative character. I've seen systems and built systems myself that kind of break at that dash line, like 4-4, but that makes it tricky if you have like -4-4. So anyway, comma saves the day here. Now we're going to fire this up and see it working in a second, but before we do that, let's come back to overworld map. And instead of just doing one here, I'm going to paste in a few more. And here's how I got these values. See, I've got 8, 6, 7, 7, 8, 7 also. To get these numbers, I'm opening up the map in my favorite pixel art editor of choice. This is Asprite. You can use whatever you want. I really like Asprite. I'm going to show you how to do it in here, but you can do it however you want. You can even just count manually. But in Asprite, if you open up the asset and then turn on the grid, so that on Mac is Command apostrophe, you'll see that the blue grid lines appear here. When that's activated, you can see another little bit of number showing up down here in this area of the screen. And if I just put my cursor on this cell, you can see at the bottom it says 7, 6. This one is 8, 6. Down here 7, 7. And then down here is 8, 7. And so that's where these numbers are coming from. So we've piped all those numbers here into our utility. So we should be left with an object that has a few different walls on it. Let's go ahead and see this working. If I go into our overworld file, right at the bottom in init, when we create the new overworld map, I'm just going to console.log this.map.walls. Let's fire up the browser now. When I reload, you can see that when the map starts, we get this log here. It's got 4 entries here. It's our same XY coordinates, but they've all been converted to bases of 16 or multiples of 16, and then separated with a comma here. So these values or these keys are going to be what we use to check if a space is free or not. So as you remember, our hero game object is wired up to the arrow keys, and when we hit an arrow key, it's going to instruct him to move to that next cell based on the direction that he's facing. What we want to do now is ask, hey, is there anything at that cell that I'm going to move to? If there's nothing there, you're free to move. If there is something there, you can't do it. So to get that next position, we know the hero's position now, and we know the direction that the hero is facing. So we're just going to create a nice little utility that puts those two pieces of information together for us and gets back our next theoretical position. That's a pattern we're going to be using a lot, so it's going to fit nicely into one of these utility functions. So we're going to go back to the code, but first there's these leftover console logs from a previous video, the direction input one, so I'm going to go ahead and remove those real quick. Let's go to direction input, and then in here, yeah, these console logs are still here. My bad, should have taken those out. Anyway, now we can go to our utils file, and we're going to add that directional utility. So this helper function is going to be called next position, and we're going to take in an x, we'll call it initial x, initial y, if I could spell, and a direction. And then what we're going to do is, to avoid actually changing variables, we're going to capture initial x and y like this. And then these are going to be what we can maybe change. We've got a size that we're dealing with. That'll be like size is 16. And now based on the direction, we want to modify either x or y. So we'll say like if direction is going to be left, then x plus equal whatever size is. Do the same thing here for right. This isn't the most glorious code, but it's going to work great. Do the same thing here, and actually left should be minus equal size. We'll do the same things for up and down here. And now that that's all done, we can go ahead and return x and y just like this. That way anybody that uses this utility will get back a clear x and a clear y. And now that we have this helper, we can use it, so don't need that anymore. We can go over to overworld map and create a new method here. We'll put it under our drawing here. This is going to be called isSpaceTaken. And it's going to take in an x and y. We'll call it current x, current y, and then also a direction. And here now we can use that helper that we just created. So we'll say x and y are going to be equal to whatever we get out of that utils.nextPosition, piping in our current x, current y, and direction. And now we can simply return this walls and then creating our string of the coordinates here. So if there is a wall here, this part will evaluate to true. But if not, just to keep it a clean Boolean, we can say false. Now let's wire this up to fire as our hero walks around. That'll kind of help us validate if it's working right. When we're right up against the wall, it should say true, like that space is taken. Otherwise, it should be false. So to do that, we're going to go into our overworld up here, overworld.js. And here in the loop where we're passing in some state to the game object's updating part, we're going to add another piece of information. Currently, we're just passing the arrow that the human player is pressing, maybe. Next, we want to pass a reference to the map itself. That'll give us the ability to check some of these methods. So let's go into person. Currently, in the update method, there's a little piece of code here that's resetting the counter to 16. Let's go ahead and maybe at that point, log out that method on the map. So we'll say state.map.isSpaceTaken, and then we'll pass in our x, our y, oops, autocomplete going wrong, and our direction. We need to wrap all this in a console log. And then when I go over to the browser and reload the page, when I move the hero around, I'm going to get a true false back on if that next space is free or not. So now when I'm about to go into a wall here, when I hit right, you can see that it goes true. And if I go back into a free space, it's false again, false, 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 false. And then here again, I'm right against the wall. So in theory, we want this to not do anything, but currently our code is still just letting it go through. So we might be thinking, okay, we can just take this check here and maybe do it in here with this logic, and then that'll stop the character from moving when they're not supposed to be able to move. But there's some nuance with like the direction here, and then there's just already kind of a lot going on here. We're going to take this opportunity to refactor a lot of our updating code. It's going to give us a little bit more organization right now, but also it's going to better set us up for a system we have coming in the future regarding NPC puppeting. Currently, the only way for our characters to move is for the human player to be touching arrow keys. But in the future, we're going to introduce a system where the overworld itself can kind of puppet people around based on a predefined cutscene sequence. That's also going to tap into a lot of the moving code here when characters should be moving around. And so we need to kind of carve out some space for that system to come in later. First, we're going to add a little bit of logic on when these two lines are actually called. So what I'm going to do is move this check from update position up to our update method and separate these two out. So we're only going to call this update position if this value is greater than 0. Otherwise, we're going to do something else. Now we're going to move our start walking code into this else block here, but we're going to do it in a way that's a little bit more explicit. I'm going to take our code as it is here and move it into a new method called start behavior. And that's going to take the same state. It can just be passed right through. And then it's also going to take a behavior object. And that's going to look like this. It's going to have instructions on it like type walk, and then which way do we want to walk. So direction is going to be whatever state.arrow is. Let's define that method now. So start behavior. Again, it takes in the state and then a behavior object to read. Paste it in our code from before. We can change some of the code in here now to be reading from the behavior instruction. So direction should be whatever behavior.direction is. And then we're going to nest the further lines in a check to make sure that we're talking about the walk command here. So if behavior.type is equal to walk, then you can go ahead and do this other stuff. And again, this is a way for us to explicitly fire a walk command on a person without it necessarily having to come from the arrow keys. Those lines won't be so tied together. Now we're actually going to use our validator check here. And so instead of doing it in a console log, I'll just copy the inner part here and say if the space is taken, we're just going to stop the function right here. So don't proceed on to where we'd start the actual moving. And we'll see in future videos that in situations where NPC people want to walk a certain way, but maybe the path is blocked, like a different person's in the way or a game object's in the way, they can keep rerunning this start behavior, start behavior, start behavior, start behavior. And as soon as that space isn't taken anymore, this part will go through and then they'll go ahead and walk. Let's go ahead and add some comments here just for later clarity. So here we're setting the character direction to whatever behavior has. Here we're going to stop here if space is not free. And then finally we're going to say ready to walk. Let's come up here and finish putting this part together. So we're going to take this block here and move it to in our else case that we set up before. And we're also going to move this update sprite call to be within the else case. And then we got to this else case by checking moving progress remaining's value. And so we don't need to check that anymore. So I'll go ahead and take this check and remove it. And remember, like I said before, this is only one of the cases that we might fire off this instruction to walk. And so let's go ahead and just add a comment here. So in this case, we want to, let's see, we're keyword ready and have an arrow pressed. Keyboard ready here means that it's okay for a player to be providing input. Later on in the game, we're going to have cutscenes that are going on, and we don't necessarily want the player to be able to provide arrow direction when those things are going on. And so that's what keyboard ready means. Up here in this space, we'll say more cases for starting, for starting to walk will come here. Clean this up just a little bit for fun. And now the timing that we're calling update sprite is a little bit different, and so we can actually change its implementation. So I'll come down here and make some changes. So based on our new updating code, we can basically just make this be this much. And then if we are going to start walking, we'll return here. If not, we can go ahead and fire off the idle, and then all the other logic can go away. We also don't need our state being passed in anymore. Now, after all that refactoring is done, let's go ahead and fire up the browser and make sure everything still works. So here we are, I'll hard reload. And when I do the arrow keys, he still moves, he still animates as we want. But when I go up to a wall here, the right command's no longer gonna work. So I can kind of like go around it. Can't come in from the top, can't come in from the side. It's working fine. Now it's worth mentioning that areas in our map that aren't walked as walls can still be kind of barged through, like here. So at this point, it's on us as map authors to come in and make sure that every single space is filled in that object. I've mentioned the idea of an editor before in this series, In theory, if we were making a ton of maps and they were large, we'd probably create a different tool for us to easily add and remove these walls. The advanced version of this course will tackle that in future videos. For now, I think the manual way is fine, and it's always a good way to get started. So now we have a basic implementation of walls, and it's working great. But there's another thing that we need to consider, and that's the position of other game objects. See, right now I can barge right through other characters, and if they were the ones walking around, they could barge right through me. There's no consideration on where are the game objects when we're checking for collisions. So to achieve this, the game objects are going to start editing that bucket of walls that we have. So when a game object is placed, we want to add a new wall. If that game object moves, we want to change that wall's position or remove it and add a new one. So let's pop back to the code. And the first thing we need to add is a way for these game objects to add or remove walls from the map wall list. And so let's pop open to our overworld map. We're going to make some new methods here. Again, I'm in overworld map, the class. This is going to be basic kind of CRUD stuff. The first one we'll do is add wall. That's going to take in an X and a Y. And this is going to look the exact same as this bit up here. But we're going to say the wall at this position, X and Y, is going to be equal to true. And now we can take the same idea and copy it and change it to be remove wall. Also going to take in an X and Y, but instead of setting something to true, we're going to throw delete over here. So if a wall exists at this position, it'll be removed from the object. And then finally, we're going to add one for moving a wall, which is a little trickier, not too bad though. So it'll be called move wall. It's going to take in a was X, was Y, and then a direction that we want to move this wall. First, we're just going to remove the one that was there. So that's was X and was Y using the method we just created up here. And now we can reuse that utility that we created at the beginning of the video. So X and Y is going to be equal utils.next position, passing in the was X, the was Y, and the direction. So this will give us an XY position of our new wall. And now we can take this new XY we have and add a wall there. So we'll say add wall, passing in that X and Y. So when all of this is done, we'll have removed the wall that was at the old position, created a new one offset by the direction, and then added the new one at that direction. So we should end up with the same amount of walls, it's just one of them will be moved. And so in practice, when a game object enters the scene, we want to fire off this add wall at their initial position. If they move at all, we want to fire off the move wall so that their wall position stays up to date. And then in theory, if they'd exit the scene, we'd fire this remove wall. We're not actually going to see a clear exit in this video, but again, like I said before, that'll come into play in future videos with objects entering and leaving the scene and such. Next, let's add some state to our game object to determine if the object is mounted or not. So we can go over to game object, and right up here, right above X, we'll say is mounted. We're going to assume false, but we're going to create a new method here called mount. And mount is going to go ahead and set this dot is mounted to true. The map will be passed into mount, the mount method here. And so because we'll have access to it, we can go ahead and say map.addMap, which is that method we just created, and then give it our current position. So this .x, this .y. So now we want our overworld map to start calling mount on each map's individual objects. So we'll come over to overworld map and create a new method, how about right here, called mount objects. And here we're going to iterate through all of the values of our game objects. So that's this dot game objects dot for each object. We're going to call o.mount. And again, we need to pass in the map, which in this case is this. So in the future, we're actually going to beef this up with some more logic that should determine if this object should mount or not. For example, maybe the object is a key and we've already picked up the key. Well, then if we've already picked it up before, then when the map loads, it shouldn't render again. But we're not going to worry about that right now. I'll just leave a comment. Say to do determine if this object should actually mount. I don't know why I used the key example because this game does not have keys in it, but you get the idea. We need some kind of concept on has this action happened or not. We'll get to that in future videos. For now, we can just call this when the map starts. So go to overworld.js and then down here in the init, when we added this console log, we can just take that out and say this.map.mount objects. And just to confirm that's happening right, let's go to game objects, and maybe in here we'll say a little mounting. Okay, let's fire up the browser and see it working. I'll hard reload. Uh-oh. Oh, I spelled something wrong. Of course. Okay, so back to add map. It's not add map, it's add wall. My bad. Comment if you saw that before I did. Okay, so I've reloaded the browser and we see our mount message successfully. That looks good. And so I can kind of walk over here, and when I try to bump into the character now, it doesn't let me because the character on mount is placing a wall right there. But we're not actually moving walls as the game objects move around yet. So as the hero, if I try to walk back to where I started in the map, I can't because the hero spawned, left a wall there, and then we haven't moved the wall since. So let's do that now. All we need to do is find our code that kicks off the walking person, and we left ourselves a nice comment, right, that said start behavior, ready to walk. Before we start walking here, we're going to go ahead and fire that method off that we created called move wall. So it's going to be state.map move wall, passing in the current X, current Y, and the direction, and this thing will take care of setting a wall at our future position. That'll also serve the purpose of reserving that space for us because we're setting a wall there when we're about to move to it, so anybody else that tries to move there won't be able to. Now I can move around, but I can successfully move into the spot that I spawned in. So for every step the hero's taking, his wall is moving along with him. So we've now established all the spaces that can't be walked to in our map, but in the next video, we're going to shift our focus to exciting things that happen when you do walk on certain spaces. For example, maybe I step on a space and more NPCs like barge into the room, or I step on a transition space and I'm transported to a different map. We're going to start diving in on that cutscene system, and that's going to help bring all these things to life. Thank you so much for watching this video to the end. As usual, if you're getting value out of the series or the video, please hit the like button and subscribe for the whole thing. If you're working on a game of your own, you should join our Discord community. We have a really great group of people in there that are making and playing indie games, so whatever you have going on, drop in there, tell us about it. We'd love to see you there. Thank you so much. See you in the next episode.